The 3000 series are formable, corrosion resistant, extremely weldable, and stronger than the 1000 series. Their applications include radiators, air conditioning, condensers, evaporators, heat conditioning, heat exchangers. A major use in the beverage and soft drinks is the can bodies, and the 3000 series are also extensively used in packaging. We now come to the 4000 series. And the 4000 series was strangely developed. Aluminium has low melting points, high thermal conductivity, and high liquidity. All of these pose problems for thermal and fusion welding, as the high welding temperatures melt the parent metal, and whilst you're trying to weld, you end up with a casting, a pool of liquid aluminium. So the metallurgists developed the 4000 series, which use silicon as the major alloying major alloying element, in additions from about 0.6 to 13.5%. So quite large alloying elements of silicon. Silicon substantially reduces the melting range. For example, alloy 4145 has an extremely low solidification temperature, 521 degrees C, compared to pure aluminium at 660 degrees C. So by alloying aluminium with silicon, the 4000 series have low melting temperatures, much lower than pure aluminium or other alloys. Silicon also increases the fluidity of the 4000 series, with the 12% alloys having the fluidity of water. Hence, silicon alloys are used extensively in castings. The combination of low melting point, below that of most wrought aluminium alloys, and the high fluidity of the 4000 series means that the 4000 series are used as filler wires for fusion welding. The lower melting point of the filler wire during fusion welding means that the filler metal melts without melting the parent metal, and then flows into the parent metal joint without collapsing or melting the parent metal. The other properties of the 4000 series is that they are formable, corrosion resistance, and welding. And for the purposes of this course, the main uses are welding and brazing filler wires. Now come to the 5000 series. As ever, industry, particularly the automotive industry, required higher strength with formability and corrosion resistance and weldability. So the weldable 5000 series were developed. In the 5000 series, the major alloying element is magnesium, up to 6%, with small additions of manganese. The 5000 series are not heat treatable, but on work hardening or strain hardening can develop moderate to high strength. Alloys in the 5000 series have good welding characteristics. They also have relatively good corrosion resistance. 5000 series have a wide and useful portfolio of properties, so they are a workhorse of the alloy series, offering strength, good formability with excellent corrosion resistance and are highly weldable. Being a workhorse, their uses are wide, including automotive, truck and train bodies, buildings, marine and chemical tankers, and generally keep the rain out panels like bracketry. Next time you take a drink out of an aluminium beverage can, realize that the body is a 3000 series alloy, but the can is a high strength 5000 series alloy. The use of the 5000 series means that you can pull the tab off without ripping the lid off the can. We now come to the 6000 series. Now, alloys in the 6000 series contain two alloying elements, silicon and magnesium, approximately in proportions required for the formation of magnesium silicide. So the two elements act in unison. The 6000 series were developed for extrudability, for extrusions. The 6000 series are readily heat treatable, developing high strength, although not as strong as most 2000 and 7000 series alloys. The 6000 series have good formability, good weldability, good machinability, and relatively good corrosion properties. Summarizing the 6000 series, they are strong, formable, weldable with good corrosion resistance, extensively used for extrusions. The 7000 series were initially developed to combine strength and lightweighting for aerospace. In the 7000 series, zinc in amounts from 0.8 to 8.4% is the major alloying element, coupled with smaller percentages of magnesium and other elements such as copper and chromium. 7000 series are heat treatable and offer medium strength. Not as strong as the 2000, but still strong. They have limited workability, so are only suitable for simple extrusions. The higher strength 7000 alloys exhibit lower resistance to corrosion, although somewhat better than the 2000 series. So the 7000 series are strong, not quite as strong as the 2000 series, but have better corrosion resistance than the 2000 series. The drawback of the 7000 series is poor weldability, hence aircraft are riveted together. 7000 series were developed for strength and lightweighting with medium to high strength and machinability. They offer poor to moderate corrosion resistance. The main limitation of the 7000 series is being their limited weldability. The uses of 7000 series include airframe structures, mobile equipment, and other highly stressed parts, armored vehicles, bicycle frames, train chassis. You're probably touching a 7000 series alloy at this moment, as they are used for laptop cases and iPhone bodies. We now come to the final series, the 8000 series. The 8000 series were initially developed for electrical conduction and composite materials, but now include medical and nuclear applications. All the other series were incrementally developed for a specific property. For example, the 6000 series from extrudability. So now all of the alloying series up to the 8000 use a major alloying element. Unfortunately, the 8000 series break the rules as they are effectively a mop-up group. They mop up all the other elements not included in the other groups, such as iron, lithium, nickel, tin, silicon, and even the odd element cerium. Studies of the 8000 series highlight some of the unique characteristics of the aluminium alloys. Aluminium, iron, and nickel offers good strength electrical conductivity. The 8000 aluminium lithium alloy creates high strength and stiffness with low density, 10% lighter than any other aluminium. The aluminium tin alloy gives high corrosion resistance and strength. And the aluminium iron silicon 8000 series give good formability, ductility, and corrosion resistance. I have a short video which explains the alloying properties and of the series and their properties. I trust you now understand the importance of the alloy series. Please see further reading. Thank you very much.